On October 31, 2025, just 2 days after reaching its closest point to the Sun, a faint smudge of light appeared on a telescope monitor at Lowell Observatory in Arizona. That smudge wasn't just another comet. It was Comet 3I Atlas, only the third interstellar object ever confirmed to pass through our solar system. For weeks, it had been completely invisible, hidden behind the Sun in what astronomers call solar conjunction. But now, just as expected, it's come back into view. The very first optical image of its return was captured by Qicheng Zhang, a postdoctoral researcher using the Lowell Discovery Telescope. He also confirmed that the comet could now be seen with small amateur telescopes, provided the conditions are right. This moment marks the beginning of a critical observation window. As 3I Atlas moves away from the Sun, astronomers hope to study it in more detail and possibly learn more about its composition, its age, and its place of origin outside our solar system. So how was this image captured? What does it tell us? And why is 3I Atlas such an important object in modern astronomy? Let's break it all down. Comet 3I Atlas reached perihelion, its closest point to the Sun, on October 29, just 2 days before the image was captured. At that point, it came within 1.4 astronomical units, or about 130 million miles of the Sun. Not close enough to threaten its survival, but close enough that Earth-based telescopes lost track of it in the glare. During this time, most of the tracking had to be done using radio observations or space-based telescopes equipped with coronagraphs. But ground-based optical observations had to wait. On Halloween morning, Qicheng Zhang used one of the few telescopes large enough and versatile enough to track an object so close to the Sun and low on the horizon, the 4.3-meter Lowell Discovery Telescope. Zhang had also been running early tests with his personal 6-inch telescope, scouting for visibility conditions just before sunrise. Using both instruments, he was able to locate the comet when it was just 5 degrees above the horizon and 16 degrees away from the Sun, barely within a safe window for observation. The resulting image showed a faint, hazy streak, not bright, but clearly moving and unmistakably a comet. This is believed to be the first post-perihelion optical image of 3I Atlas from Earth. Even more interesting, Zhang confirmed that the comet can now be detected by amateur astronomers using standard backyard telescopes, provided the eastern horizon is clear and observations are made during the brief twilight window before sunrise. Right before perihelion, astronomers noticed something unusual. Using spectral data and photometry, Zhang and colleagues found that 3I Atlas had started to brighten much faster than expected as it approached the Sun. They posted their findings on ArcZiv on October 28, just a day before perihelion. The brightening wasn't just due to reflected sunlight. There was evidence that gas emissions were playing a major role. These emissions, likely caused by the sublimation of ices like carbon dioxide or carbon monoxide, created a noticeable blue tint in the comet's glow. That blue coloration is important. It suggests that the comet's composition may include volatile gases that aren't usually seen in comets native to our solar system, or at least not in those that have orbited the Sun repeatedly. Because 3I Atlas is on a hyperbolic trajectory, scientists are confident that it originated outside of our solar system. Its path is too straight and its speed too high, estimated at over 130,000 miles per hour, 210,000 kilometers/a, to be gravitationally bound to the Sun. The comet is believed to be making a one-time pass through the inner solar system before continuing back into interstellar space. The possibility that 3I Atlas is shedding fresh, unaltered material, possibly for the first time since it formed billions of years ago, makes this observation window extremely valuable. Researchers can study how the object reacts to solar heating, what gases are released, and whether the outer layers differ from the inner ones. Now that the comet is moving away from the Sun, it becomes easier to observe. The glare is less intense, and the comet is climbing higher above the horizon each morning. According to Zhang, in just a week, it will be 25 to 30 degrees away from the Sun, putting it in a better position for a much larger number of observatories, both professional and amateur, to track it in detail. The post-perihelion phase is especially important for one reason: outgassing. As the comet moves away from the Sun, any ices on its surface that were heated will continue to sublimate, releasing gas and dust. These emissions can be analyzed using spectroscopy to determine chemical composition, isotope ratios, and even dust particle sizes. Some preliminary theories suggest that prolonged exposure to interstellar radiation has significantly altered the comet's surface. It may now have a hardened, irradiated outer shell, a kind of crust that protects whatever lies beneath. If true, this makes it harder to identify exactly where 3I Atlas came from. But it also makes the inner material, once exposed, even more valuable, like peeling back the outer layer of a time capsule. The current window for observation is short. As the comet continues its outbound journey, it will eventually become too faint for easy detection. That's why this period, from early November through mid-December, is expected to produce a flood of new scientific papers, telescope time allocations, and public updates. If you're an amateur astronomer, there's a good chance you can observe 3I Atlas yourself with the right setup and conditions. To begin with, you'll need a telescope with at least a 6-inch aperture to pick up the comet's faint glow. It's also essential to be in a location with a very low eastern horizon. Since the comet rises just before the sun, the sky should be clear, with low atmospheric humidity, to avoid distortion near the horizon. Most importantly, timing matters. The best observation window is typically 60 to 90 minutes before sunrise, when the sky is still dark but the comet has just begun to rise. Keep in mind, this won't be a dazzling show. You likely won't see a dramatic glowing tail or a bright nucleus. Right now, 3I Atlas appears only as a faint smudge, but it's a detectable one, and it will become easier to spot as it climbs higher in the sky with each passing day. Zhang has already shared what the comet looks like through a small telescope on his commentary blog, providing a helpful reference for others. Thanks to publicly available tracking data and consistent updates from observatories, even amateur observers can contribute meaningful data to this historic event. Several astronomy forums and online communities are now actively sharing coordinates, images, and tips for locating the comet. This cooperative effort is helping to refine tracking across the Northern Hemisphere. So far, astronomers have gathered a number of key facts about Comet 3I Atlas. It was discovered in July 2025 by the Atlas Survey, which scans the skies for incoming objects. The comet is on a hyperbolic escape trajectory, meaning it is not gravitationally bound to the sun and will never return once it leaves. It reached perihelion, its closest point to the sun, on October 29, just before it disappeared into solar conjunction. Its speed is also noteworthy. 3I Atlas is traveling at roughly 210,000 kilometers per hour, much faster than typical solar system comets. It has shown signs of emitting blue gas, likely carbon dioxide or carbon monoxide, as it heated up. Observations also suggest that its outer layers may be heavily irradiated, the result of traveling through interstellar space for millions or possibly billions of years. As of early November, the comet has reappeared and is once again visible from Earth with the right equipment. But despite this growing list of observations, many important questions remain. Astronomers still don't know where exactly it came from. Its true age is also uncertain, though one study suggests it could be as much as 3 billion years older than our solar system. Scientists are also eager to learn what types of gases and ices make up its core. And as the comet continues its journey away from the sun, the question remains, will it behave like a typical comet or surprise us with further unexpected changes? Finally, while most scientists agree that 3I Atlas is a natural object, a small minority continue to entertain the possibility of non-natural origins, especially given its unusual trajectory and structure. For now, the priority is clear. Collect as much data as possible while we still have the chance. Comet 3I Atlas has returned to view, and with it comes one of the most exciting opportunities in modern astronomy, the chance to study a truly alien object up close and in real time. Whether you're an astronomer, an enthusiast, or someone just curious about the universe, this is a rare moment. We don't get many interstellar visitors, and we don't always get a second chance to see them. Be sure to subscribe for the latest updates on 3I Atlas, interstellar comets, and all the most important discoveries happening across the universe. Thanks for watching.